Hello, everyone. Welcome to our very first episode of Lido Community Staking Educational Series. So it's a series that are designed specifically for newcomers to crypto, as well as for experienced crypto community members who are eager to enhance their knowledge and gain new skills. So in the very first episode, actually it's an episode 0, we will walk you through the basics of Ethereum, the validator duties, the penalties, slashings, and the requirements for the validator. And looking ahead a little bit, I would like to say that the next 2 episodes will be devoted to the topic of setting up a DVT validator, so stay tuned. But getting back to our today's topic, today we have Dmitry. Dmitry is a contributor at Lido, and he will give us an overview of validation on Ethereum. Dmitry, hello.
Yay, hello. Let me share my screen.
Sure.
Okay, can you see it well?
Yep.
Great, so let's get started. As Sasha said, today we have episode 0 of our community staking education series, and we're gonna be talking about very basics of Ethereum validation, the things that everyone need to know to become Ethereum validator. Okay, without further ado, let's get started. So Ethereum, you've heard of Ethereum, and do I even need to explain you why Ethereum is such a great ecosystem, such a great blockchain network? Probably not, but let's do just a quick recap. Initially developed based on ideas of Vitalik Buterin and currently developed and supported by enormous amount of enthusiasts coordinated by Ethereum Foundation. Ethereum is by far the most advanced and the largest cryptocurrency or blockchain in whole crypto to offer DeFi applications and the whole ecosystem on top of it. Unlike Bitcoin, on Ethereum, you can actually build your applications. You can build financial and non-financial products that will operate on a blockchain and not just transfer your ETH from one wallet to another. If you are long in crypto, you might heard of Ethereum mining. And now we are talking about Ethereum staking and Ethereum validation. And both of these terms are true. And the transition from mining or proof of work based consensus mechanism to proof of stake based consensus mechanism actually happened in September 2022 on the event called the Merge. On this event, the whole Ethereum network transitioned from being secured by proof of work based consensus mechanism or mining to proof of stake. And Beacon Chain, the chain where validators and all this staking happens, actually was introduced at least half a year, 1.5 years before the merge to properly battle test all the things. So for a while, there has been Ethereum mining and Ethereum staking at the same time. But now it is only Ethereum staking. As the result of merge, there are now 2 blockchains on Ethereum, not 1, but 2. The first one being execution layer, also known as Ethereum 1.0 or previously just Ethereum. This is the blockchain where your transactions and smart contracts live. And most of the users, like I would say all of the users except for validators, interact with execution layer, because if you want to submit transaction or interact with a smart contract, here you go, you need execution layer. But to reach consensus and to protect execution layer from any bad things happening and to actually make it develop to extend execution layer, consensus layer blockchain is introduced, also known as Beacon Chain. And on consensus layer, on a separate blockchain, actual attestations and block proposals live. On this blockchain, validators reach consensus about what block should be next on execution layer, and is this block valid or not, and the rest of the stuff. Actual Ethereum consensus mechanism is called Gasper. Not to mess with proof of stake, because proof of stake is not a consensus mechanism. It's just the idea that you need to provide something as a stake to participate in the network. and the actual consensus mechanism on Ethereum, again called Gasper. And this pretty strange name came from the fact that there are two consensus mechanisms combined together. The first one is LMD Ghost, or Latest Message Driven Greedy Harvest Observed Sub-Tree. What a complicated name. And the second one, Casper FFG, or Casper Friendly Finality Gadget. Let's take a closer look on both of these mechanisms and find out for which purposes each one of them serves. We start with LMD Ghost. LMD Ghost serves for the fork choice. This is a crucial part of the consensus mechanism for any blockchain, for any network utilizing blockchain, because from time to time, blockchains might get into a situation where there are several versions of a blockchain starting from the same block, and the participants of the network, they need to select each one or which one of those two is valid and using which one they should build new blocks on. The most common fork choice mechanism that is used for the majority of the proof of work blockchains is the longest chain approach. According to the longest chain approach, as you can see on the picture, it becomes obvious that chain A, B, D, G should be chosen since it is the longest chain. And while for proof of work, it really works, because to build new block in a proof of work blockchain, you need to put a lot of efforts into building this block. You need to solve this mathematical problem, basically by guessing this addition, and spend tons of computational power. On proof of stake, with proof of stake, the situation is different. You do not need to spend enormous amounts of resources to build a block, because your validator is assigned to produce this or that block. And when your validator is assigned to produce a block, it is up to you to select on top of which block you will build your block. And if you are, for some reason, either lacking network connection or probably you are a malicious actor, you can build not on the latest observed block, but let's say on a block in the past for some reasons. And that might result in the situation where there are multiple forks in the network. So how to tackle this problem within proof of stake based consensus mechanism? The answer lies in LMD Ghost. And using this fork choice mechanism, chain ACE will be chosen as the most preferable one. Let's find out why. As you can see, there are numbers on top of blocks. These numbers indicate the number of validators voted for this block to be the last block in the observed blockchain. The more the number is, the higher the weight of the block. And since you see this subtree thing in the name of the consensus mechanism, it means that we not only sum up the votes across the longest or across the chain, but across the subtree. Let's take a look at block C, for example. It has weight of 30, but the connection between block C and block A weight 65. And 65 is not a sum of 30 and let's say 20 for block E, but it's a sum of all weights of all blocks built on top of block C plus the weight of a block C. Hence, we have 65. Now let's try to reproduce the fork choice mechanism, imagining that we are responsible for choosing fork and we are using latest message-driven greedy harvest observed subtree mechanism. We start from the last finalized block A, and then we calculate all the weights for all the blocks and all the connections, and then select the heaviest connection. In our case, it is connection between block A and block C. We move to block C. Okay, we are at block C. What to do next? Next, we repeat the process and select the heaviest connection one more time, and we move to block E. And block E is the last block in the chain. No more blocks are built on top of block E. Hence, we arrived at the correct fork, at the heaviest fork or heaviest observed subtree. Latest message-driven prefix in this mechanism means that only last vote by each validator is taken into account. So if your validator at some point in time voted for block B and then voted for block F, only vote for the block F will be taken into account. Now let's talk about Ethereum finality and Casper FFG. We wouldn't dive too deep into how the finality is actually reached right now. We will dive into it a bit deeper. But for now, what we need to know is that finalized blocks and all his ancestors can never be changed or reorged. Why it is needed? If we only have a mechanism for choosing fork, then there is no guarantee that once upon a time, another alternative version of the blockchain will be revealed with the blocks having weights way more than the blocks in the previous chain. And this new version will be treated as the best fork choice. Hence, all the previously observed blocks will be reorged and will no longer be in the blockchain. Even though the possibility of this situation is extremely low, there is still some possibility. And to overcome this issue and to exclude situations where huge reorgs are happening on a network, finality concept is introduced. So each time when network participants start choosing the fork, they start from the last finalized block and not from the genesis block. But since it is an additional tool and it is not required for actual network operation, because fork choice mechanism is basically enough for network operation, comes the fact that network finality is not guaranteed. It might be reached, it might be not reached. Anyway, network will continue operation. And we will know why network finality might not be reached a bit later. So let's sum it up. Ethereum consensus mechanism is called Gasper, and it is made out of two separate mechanisms, LMD Ghost and Casper FFG. LMD Ghost serves for fork choice, and Casper FFG serves for finality. Great, we can move on. If you want to learn even more about consensus mechanisms and learn these peculiarities and special things that I wasn't able to cover in this series, make sure to check out ETH2 book written by Ben. From my point of view, it is one of the best resources available to learn more about Ethereum. Now let's take a look at Ethereum network itself and two things, nodes and validators, because these two things are separate in Ethereum network. Node is a piece of software responsible for communication with the other nodes, to maintaining state, and to do several other things, which we learn about later. And validator itself is not connected directly to the network, but connected to the node and utilize node as a proxy to communicate with the network. And there might be as less as 0 validators per node. So you can just run Ethereum node without need to stake Ethereum or do whatever. You can just run your node and be a part of a network. But if you want to run validators, you need to run a node plus validators. And you can run up to infinite number of validators per one node. But I wouldn't recommend running more than 100 validators per node due to possible performance issues in this case. As we discussed before, Ethereum is actually made out of two blockchains. So there's actually two nodes or clients, execution layer client and consensus layer client. While execution layer client might operate independently without consensus layer client, so you can just run execution layer client on your own and use it to communicate with the network, to submit transactions, to read data from smart contracts or about balances of other participants. With the consensus layer client, the situation is a bit different. To run consensus layer client, you need to also run execution layer client, because consensus layer client should be connected to execution layer client. And if you want to run a validator, you need to connect it to consensus layer client. So the typical setup for Ethereum validation looks like this. It's the execution layer client, consensus layer client, plus validator client. So you need 3 pieces of software to run Ethereum validator. And there's one optional thing that you can also run is MEV boost client. But what it is and what MEV is. MEV stands for maximum extractable value. This is additional value that authors of the transactions are willing to pay for the block proposer to include their transactions in a specific order or faster than the other transactions or for many other reasons. And this is extra value or extra tips, as you might call it. That is called MEV. If you want to learn more about MEV, make sure to check out the first link on the slide. And if you want to learn more about specifically MEV Boost software that is connected to Validator client, make sure to check the second link. And we are moving further. Now let's talk about duties of consensus layer node and validator. And here I want to stop for a second. Why? Because as you might see from the slide, name or term validator is probably the worst possible term to name this piece of software on Ethereum. And the reason is simple. Let's take a look at responsibilities of consensus layer node. Consensus layer node is responsible for validating blocks. Consensus layer node is responsible for selecting, fork, and communicating with the network. So validator itself doesn't validate actually anything. But why? And what validator actually do? Responsibilities of validator is to propose blocks, to attest chain state, and to report slashings. But how it might be that validator is not validating anything? As you learned from the previous slide, validator use consensus layer node as a proxy. So these duties are intentionally separated. You cannot run validator without consensus layer node. So if you are running validator, you are sure that your consensus layer node is actually validating blocks. But on the other hand, to run a validator, you need to have 32 ETH. But if you don't have 32 ETH, you can just run consensus layer node on its own and still validate blocks and still select forks and still contribute to Ethereum security without need to stake 32 ETH. You wouldn't get any rewards in this case for sure, but you will contribute to network security. And if you run validator alongside consensus layer node, you will also be responsible for proposing blocks, attesting chain state, and reporting slashings. And you will get rewards in this case. Okay, let's talk about validator duties in more details, because today we are talking about Ethereum validation. The first duty is block proposing. And here the things are pretty simple. Validator should propose valid blocks, both in terms of payload, namely transactions included into the block, and in terms of attestations included into the consensus layer block. And validator should propose blocks in time, because there's a fixed slot for each block to be proposed, named exactly 12 seconds long. Everything's simple with block proposal. With attestations, the situation is totally different, because imagine the case when each validator in the network, and at the moment there's around 1 million validators in Ethereum network, will attest each block in the network. It will be a huge load on the network, and there's no chance for these blocks to ever be small. These blocks will be huge. That's why Ethereum consensus layer blockchain is separated into epochs, each epoch consisting of 32 slots, and each slot is 12 seconds long, as we learned before. Before each epoch, all validators are split into 32 committees. Each committee is assigned to a given slot within epoch, and validators in a given committee will attest only the slot assigned and not the rest of the slots. That means that each validator should attest exactly one block per epoch, or one block per 32 slots. Actual vote or actual attestation is a vote, and it is a vote for the chain state consisting of 3 subvotes: head vote, source vote, and target vote. Head vote is required for fork choice, and while source and target votes are required for finality. Let's find out how. You've already seen this picture, right? Yeah, we've seen this picture when we were talking about fork choice mechanism. And you've noticed these numbers on top. This is the number of head votes for this or that block. It means that 10 validators voted that block B is actually the last block in the block in that should be placed in the given slot by the validators attesting slot where block B was placed. And for block C, 30 validators voted, and so on and so forth. Based on this votes, the fork is chosen. With the source and target votes, situation is a bit more complicated. Let's return back to the finality concept. As you remember, beacon chain or consensus layer blockchain is separated into epochs, and the first slot in each epoch is called checkpoint. And network is finalized not block by block, but checkpoint by checkpoint. So each time new iteration of finalization happens, and if it is successful, so the very first block in epoch is finalized, and all his ancestors are also finalized. So there are two votes: source vote, or no, let's start with target vote, right? Target vote is a preliminary vote for finalization. While submitting target vote, validator votes for the block that he thinks should be in a checkpoint n+1, and that this block with this hash should be finalized on the next round of voting. While source vote is the hash of the block for the checkpoint n that validator previously voted for as target vote. But why do we need two votes here? It is needed to ensure the agreement between validators. When submitting target vote, the validator also listen to the network and check how many other validators voted for the same target block. And it will submit this hash of a block as a source vote on the next round only in the case if 2/3 of the network also voted for the same target vote. So there's the preliminary agreement about the block to be finalized, and on the next round, this agreement is settled and the block is actually finalized. And you notice the important thing here? Yes, 2/3 of the network should vote for the same target and then for the same source block to be finalized. That means that there might be cases when finality is not reached, when, for example, half of a network vote for one block and half of a network vote for another block. This is not the case for fork choice, because for the fork choice, you need at least one vote difference, while for finality, you need 2/3 of the network to agree on the same version of the blockchain. Okay, now let's move to another duties of validator. And the next duty here is sync committee participation. The main goal of sync committee is to aggregate head votes to allow light clients operation. What does it mean? Even though each epoch, all validators are split into 32 committees, each committee is still consists of a huge number of validators. And if all the votes in original form will be included into the consensus layer block, the size of the consensus layer block will be enormous. And it will be extremely hard for light hardware or light software to deal with these blocks. That's why instead of including actual votes, aggregated votes are included. And validators who are in the sync committee at the moment are responsible for aggregating these votes and providing these aggregates to the block proposer. Now we arrived at the most interesting part, at the juiciest part of Ethereum validation: rewards. There are two types of rewards: consensus layer and execution layer rewards. Let's start with consensus layer rewards, or rewards acquired by validator on consensus layer. And there are four types of them: block proposals, attestations, sync committee participation, and slashing report. If you take a look at breakdown of rewards in the long term that you can see on the slide, you will see that block proposals and sync committee rewards are actually not that significant. But why? Because attestation is such a simple duty and block proposal is such a huge duty, and sync committee is also super important. The reason is simple. Even though attestation reward itself is extremely small, the number of attestations submitted by validator equals to the number of epochs passed within time. So each validator should submit exactly one attestation per each epoch. While with block proposals, with the current size of the network, typical validator will most likely produce from 1 to 3 blocks a year. So this is not a very frequent duty. And with sync committee, the situation is even less frequent. So there might be chances where during 2 years, your validator will never participate in sync committee. That's why main attestations on main rewards on consensus layer come from attestation in long term. Okay, now let's take a look at execution layer rewards. Starting from merge, all these rewards, not all, but part of them, acquired previously by miners, also known as priority fees, these extra tips that authors of the transactions paid for their transaction to be included faster into the block, are also assigned to the block proposer or validator in our case. And on top of that, there's also MEV. And you will probably ask why we can see percentages on the rewards breakdown. And the reason here is the following. You never know how this relation looks like. Is it look like this? Or does it look like this and MEV is extremely small while priority fees is huge? Or maybe vice versa. You never know, because MEV is a lottery. MEV depends on multiple external factors, namely demand in transactions, new protocol being released, or some protocol getting hacked, or some super amazing L2 or project being released, resulting in a huge demand of transactions. So you never know how much MEV would you get. Would it be huge or would it be low? So you need to keep it in mind. In a typical situation, the relation between consensus layer rewards and execution layer rewards is approximately the following. So 30% of rewards usually came from execution layer rewards, and 70% usually came from consensus layer rewards. Again, this is just approximate numbers, and execution layer rewards are way more volatile than consensus layer rewards. Now it's time to talk about not that exciting topic, yet super important, validator penalties. Unlike many other blockchains or networks, on Ethereum, validator can actually be penalized. And there are several cases when validator can be penalized. The first case is missed attestation. Let's find out why in this case validator will even be penalized. As we learned before, attestations are crucial for both selecting fork and reaching finality. And while for selecting fork, there is no threshold of the amount of validators voted for this or that block, with finality, it is a threshold, namely 2/3 of the network should vote for the same source and target. That means that if your validator should attest this block and he never attested it, he wouldn't make contribution to the network security. In this case, your validator will be penalized. The same goes for sync committee, because again, validators who are in the sync committee responsible for aggregating these votes, for doing this important job, and if you're not doing your job, you will be penalized. And the last but not the least here, and by far the scariest and the largest and the most significant penalty, is slashing penalty. Let's dive deeper into slashing itself. Let's find out how it might happen, what are the consequences, and what are the penalties. We start with conditions. The validator is slashed in case of significant consensus rule violation. We wouldn't describe all of them in details. You might read about them in ETH2 book if you want. But now I will tell you that the most common case, and by far the only case observed in majority cases of slashings on the mainnet, is double signature of a block proposal or attestation. Let's find out why double signature is treated as a significant consensus rule violation. Imagine the case. You have your validator private key, and you want to mess with the network. You want to make part of the network think that you voted for one block, and the other part of the network think that you voted for another block, so that network will be effectively split in two parts. You can easily do it. You can take your validator private key and sign two different messages, two different attestations, or two different block proposals, no matter, and propagate first message starting from Asia and the other message starting from United States. Most likely, all validators in United States will first heard about your second message, and in Asia about your first message. It will prevent network from reaching finality. It will prevent network from properly selecting fork, because different parts of the network will have different visions of the same situation. This is why this is a strict rule violation. Interesting fact here that in most cases, double signature actually happens not because of you being malicious, but because of a simple thing. You just run these two copies of validator on different machines with the same validator key. And that results in a double signature. Just a second. I need to stay hydrated to tell you more about slashing. Now let's move on to the consequences. So slashed validators are ejected from the validator set after the slashing period, usually 36 days, and are subject to slashing penalties. We will find out a bit later why the slashing period is actually 36 days, why it is so long, and why it is needed when we will take a look at slashing penalties. There are 3 types of slashing penalties. All of them are applied to the validator during slashing. So there's not a choice which one of them will be applied. All of them will be applied. The first one is initial or minimal slashing penalty. The amount of minimal slashing penalty is 1 divided by 32 of the validator's effective balance. At the current moment, it is 1 ETH. Correlation penalty or midterm penalty might vary from 0 ETH, so no correlation penalty, up to max effective balance of the validator. And missed attestation penalty is a penalty for missed attestations during all slashing period. During slashing, your validator will still be a part of the validator set, but it wouldn't be able to submit attestations. Hence, it will get attestation penalty. In a typical case, total penalties for slashing are approximately 1 ETH plus something. So make sure not to run the same validator private key on 2 machines so that your validator wouldn't get slashed. And finally, we need to take a look at slashing timeline breakdown to better understand correlation penalty and the other penalties. Slashing starts at day 1, and immediately initial or minimal slashing penalty is applied, and attestation penalties start to accumulate on your validator. In the very middle of slashing, correlation penalty is calculated. To calculate correlation penalty, network observes how many other validators are also getting slashed at the same moment. Are there any, and how much of them? And based on this number, correlation penalty is calculated. With the current size of the network, approximately 9,000 validators being slashed at the same time is enough to flip correlation penalty from 0 ETH, so from no correlation penalty, to 1 ETH, effectively making your slashing penalty twice as it was before. And then the process continues up to max effective balance. If 1/3 of all validators in the network are getting slashed at the same time, correlation penalty will be equal to max effective balance or somewhere around it. This measure is introduced to prevent coordinated attacks on the network. So if you are just messed with keys and was so unlucky to run 2 copies of the same validators, but it was only you, this is not an attack on a network, it's just your mistake, then it is not dangerous for the network. But if someone will decide to do these double signatures intentionally in a huge amount, he will inevitably be slashed, and basically all the balance or significant part of validator's stake will be burned. That's why we need to do our best to avoid slashings and operate properly. And with all this described, let's take a small, minimal look to the future. With this offline penalties for misattestation, with this slashing penalties, you are probably thinking, is there a chance to minimize these risks? And yes, it is. It is called distributed validator technology. Instead of having one single validator client, one single piece of software, you actually have multiple DV clients or distributed validator clients, each run by independent person or by your friends, or maybe some of them can be run on your own, no matter. The idea is that DVT or distributed validator is somewhat similar to multisig. Individual DV client cannot commit actions on its own. DV clients should get agreement between each other. So the majority of them should agree that this attestation should be submitted or this block proposal should be submitted, effectively minimizing cases of slashing and possibility of slashing. And also, if minority of DV clients for some reason will go offline or will lose their internet connection, while the majority of DV clients are still online, validator will still maintain his duties, and there will be no penalties, and the rewards will be fine, and network will be stable. But we will talk about DVT on our next episode, so stay tuned for sure. And if you want to know about DVT right now, just to give you the gist, scan the QR code and learn more about concept of DVT, and make sure to join us on our next series of community staking education to get hands-on experience on how actually run OBOL and SSV DVT technologies. Now, and we are very close to the end of our education today, let's talk about requirements, what you actually need at the moment to run Ethereum validator. First of all, you need 32 ETH as collateral, or also known as stake. You need Ethereum setup made out of execution layer node, consensus layer node, validator client, and MEV boost client. MEV boost is optional in this case. And you need hardware to run all this software. Intel Nuke-like CPU plus 16 gigs of RAM plus 2 terabytes SSD will probably be more than enough to run your Ethereum validator. Can you spot the main issue here? Right, it is 32 ETH. That's hell ton of money. It's not a typical case for anyone in the world to have 32 ETH. That's enormous amount of money. But is there a chance to fix this problem? Yes, it is. It is called Lido Community Staking Module. With Lido Community Staking Module, you will be able to participate in Ethereum validation while providing only 4 or maybe even less ETH as the collateral or as stake or as bond, while still maintaining the same hardware and software for Ethereum validation. And that's not the only reason to become CSM validator. For sure, CSM will be permissionless, so no conditions, only provide your bond, and that's it. Bond amount will be really low, so 4 ETH or maybe even lower. But on top of that, you will also benefit from MEV smoothing, and you would no longer need to be afraid of losing this huge MEV or your friend getting huge MEV and you not getting it, because any MEV ever extracted by any Lido validator will be smoothed across Lido staking modules. So you can be sure that you will benefit from most of MEV ever appeared on Ethereum network. Community staking module for sure will be super easy to use with integrations with well-known software partners. You will be able to prepare your validation setup within just several clicks, submit one transaction to join CSM, and then maintain your validator up and running. And the only thing you will need to do on top of running validator is to claim rewards from time to time, no more than that. And for sure, validating with CSM will be more profitable than solo staking, approximately 1.5 times or maybe even more. So if you want to take your first steps towards Lido CSM that is currently in development, we're not there yet, but we will be soon. If you want to be able to join testnet in the first rows and benefit from other educational content to learn more about CSM, make sure to claim this POAP on Galax to indicate that you're interested in participation, and probably later you will get some bonuses claiming this OAT. And once you claim the OAT, make sure to claim Discord role to join Lido CS community, our private Discord community where we share meaningful insights, latest news, where we announce testnets or any other cool activities prior to public announcements, so that you will be aware of all this stuff a bit earlier than the rest of the Ethereum community. We never talked here about how to actually run validator, and this was done on purpose. There's tons of guides, video guides, written guides about how to run your validator. For me personally, I think that a guide prepared by Sam from Stakes Hours is one of the best guides available currently for Ethereum validation. So make sure to scan this QR code to check out his guide. In this guide, you will not only find steps about how to set up validator, but a lot of tips and tricks how to properly set up your VM on this or that cloud, what additional software you should do, what additional settings you should do to make your validation experience smooth. And make sure to try it out on Halaski testnet. And if you need some Halaski ETH, make sure to join Lido CS community Discord and ask for this ETH if you are willing to run testnet validator. Okay, that's basically it for today. As usually, in ETH we trust. And one last thing, if you do want to validate with us, if you do want to join CSM, make sure to check out recent proposal on Lido Research Forum with the detailed description of CSM, of features that will be, or we think will be implemented in CSM, and leave your opinion. Do you think it's a good idea to implement CSM? Do you think features provided are great or not? And make sure to do your contribution to make CSM better, and for sure to later join CSM as one of the validators. And that's it for today. Thank you guys, and I'll see you in the next episodes. Bye.